Hey, today we are discussing manometry. So, what is manometer? Manometer are the devices used to measure pressures, and normally they are called as barometers or pressure measuring devices. Okay? So, manometer use vertical inclined liquid columns to measure pressures. So, we are having different type of manometer. On first, we have piezometer tube. Piezometer tube, you can see on the left side that here is a piezometer tube, and normally we can use these manometers in our real life in various disciplines, such that this is blood pressure measuring device. Then we have this one. So So, piezometer. The simplest type of piezo consists of a vertical tube, open the top and attached to the container in which pressure is desired. This is illustrated in that picture showing in left. Okay. Then we have a statement given below that P is equals to rho h plus P naught, means that pressure in that piezometer equals to the specific weight times the height plus atmospheric pressure or normal pressure. This statement gives the pressure at any elevation within the homogeneous fluid, means the fluid must be the same in which we are measuring the pressure. In terms of reference pressure, P0 and the vertical distance h between P and P0, so that we can find the actual pressure, and for to finding actual reading we can have to fulfill the uh, like conditions and other things. Remember that in a fluid at rest pressure will increase as we move downward and will decrease as we move upward. Application of this equation for the piezometer tube indicates that the pressure P1 or PA can be determined by measurement of H1 through the relationship. So we can find the PA or P1 at this point by measuring or taking this statement. Okay, then PA equals to gamma 1 H1, or this is called as specific weight, and this is called as height 1. So specific weight is the weight bearing the fluid contained in this tube, and height is this height from their top to bottom. This is taken as height. Okay, now the simplified form of piezometer is this. Suppose the standard point is we taken that A, and here open atmosphere and the fluid filled in this tube. So the fluid has some specific weight which is denoted as gamma 1, and at some height it is taken as h1. Okay, now this is called U-tube manometer, and it is another type of manometer. This is the simplest form of manometers showing you. So what is U-tube manometer? The piezometer is not so effective. So to overcome the difficulties noted previously, another type of manometer which is widely used consists of a tube formed into a shape of a U, as shown in figure 2.10. The figure is showing above that this is 2.10 and this is U-tube manometer. It is a simplified form of U-tube manometer. However, the real manometers are so complex so that we can use ideal or simplified or generalized form so that it may easily understandable. Now moving toward, so it is widely used and consists of a tube formed into the shape of a U and is shown as figure 2.10 as shown above. The fluid in the manometer is called the gauge fluid, and to find the pressure PA in terms of various column size, we start at one end of the system and work our way around to the other ends of utilizing. Okay. The contribution of gas column manometer is negligible since the weight of the gas is so small. So it is written that the weight of the gas is so small, so the contribution of gas column is negligible. We only considered the liquid column. Okay, so the statement for this manometer is given as PA equals to gamma 1 H1 minus gamma 2 H2. As so, to find this, we can moving upward, and from this image we can find out whether is statement true or false. So as we know that this point and this point are equal in height, so pressure is equal at the same height, always equal at the same height. Pressure never change unless the point or height change. So PA is equal to P1. So no need to write it down, just we moving towards P to V2. Sorry, gamma to V2 because it is a fluid. So gamma 1 H1 or H0 because it is a point 1 or initial point, so we note it down as PA or P1. Then moving downward, pressure increase. As pressure increase, the specific gravity is gamma 1, specific weight is gamma 1, and this is height H1. Then at this point and at this point, pressure always remains same. Moving onward, it is moving upward, and in upward direction pressure will decrease. So minus the, and it has the gauge fluid has a specific weight of gamma 2. So minus gamma 2 and H2. So here the condition satisfied, and we can find the pressure at point A or pressure at point 1 as this height. So we have to send all this stuff in the either side of PA, so we can find pressure at point A. A major advantage of YouTube manometer lies in the fact that the gauge fluid can be different from the fluid the container in which the pressure is to be determined. There is a condition in piezometer tube that fluid must be homogeneous, but in a YouTube manometer it doesn't have such type of conditions. So the gauge fluid can be different. If A does not contain a gas, the contribution of gas column gamma 1 H1 is almost always negligible, so that PA is almost equal to P2. And in this sense, equation 2.14 becomes PA is equal to gamma 2 H2. Like this, or it is saying that PA is almost equal to P2 as mentioned above, so that at this point we can neglect gamma 1 H1 because it has negligible height. Like there, pressure at point 1 is almost equal to pressure at point 2, or pressure at point A is almost equal to pressure at point 2. So we neglect this pressure and just counting this and this. So moving downward, PA is equal to gamma 2 H2. First, for a given pressure at height H2 governed by the specific weight gamma 2, if the gauge fluid used in a manometer with the pressure PA is large, then a heavy gauge fluid such as mercury can be used, and a reasonable column height not too long can still be maintained. Alternatively, if the pressure PA is small, a lighter gauge fluid such as water can be used, so that relatively large column height which is easily read can be achieved. So there is an example of YouTube manometer. So this type we are using for YouTube manometers. Problem are discussed in other video. Moving towards another type, there is the inclined tube manometer. Now, such type of difficulties occur in piezometer or YouTube manometer. So there we are using inclined tube manometer. So what is this? To measure small pressure changes, manometer of the type shown in figure 2.12. Here is 2.12. Here 2.12. Here we can see that there is an inclined surface used to measure the pressure in the manometer. So we can learn what is the work of this inclined line. So one leg of the manometer is inclined at an angle of theta, and the differential reading L2 is measured along the inclined tube. The difference in pressure PA minus PB can be expressed as, so the difference pressure can be expressed as PA plus gamma 1 H1 minus gamma 2 L2 sin theta minus gamma 3 H3 equals to PB. So we can find by seeing the picture.